Have you ever wondered why that coffee you make at home just never tastes quite like the one from your favorite cafe? Well, you're not imagining it. Today, we are going to pull back the curtain and look at the hidden physics that can turn that inconsistent morning brew into a perfect cup every single time. Come on, you've been there, right? One day your coffee is just amazing, and the next day it's just meh. You're using the same beans, same grinder, same everything. So what gives? Turns out, the answer is hiding in some pretty fascinating and surprisingly predictable science.
All right, so to solve this whole mystery, we need to get a handle on the single most important process in making coffee. It's a little concept called extraction. And this is where all the magic and, all the inconsistency really happens.
To put it simply, extraction is just pulling all the good stuff, those delicious flavor compounds, out of the solid coffee grounds and into your water. Think about it like making tea. The longer you let that tea bag steep, the more flavor you pull out, right? Coffee is pretty much the same deal, just with a whole lot more going on.
So let's dive into our first major variable, the size of the coffee grounds themselves. It might seem like a tiny detail, but in the physics of coffee, believe me, size is absolutely everything. I want you to imagine your coffee grounds are like a team of runners. You've got your marathoners. Those are the bigger bulk grounds. They release their flavor slowly and steadily over the whole race. But then you've got the sprinters, these tiny, almost dust-like particles called fines. They give you this massive, explosive burst of flavor right at the starting line.
And the speed difference between these two runners? It is staggering. A tiny 100-micron fine particle, one of those sprinters, extracts all its flavor an incredible 42 times faster than a more standard 650-micron bulk particle. Now that's not a small difference. It's a huge gap that completely changes your final cup.
And this whole thing comes down to a really simple rule in physics. See, smaller particles have way more surface area for their size, so the water can just get in there and pull out all the flavor much, much faster. The rule is pretty straightforward. As you can see from the formula, if you cut the size of a coffee particle in half, you actually quadruple its extraction speed. And that is why those tiny fines are so powerful.
All right, let's move on to our next key player, temperature. We all kind of know that hot water works better for a quick cup of coffee, but why? Well, the answer is in a cool concept called activation energy. Just think of activation energy as the little push that's needed to knock the flavor molecules out of the coffee grounds. Colder water, it gives a little nudge, but hot water, it provides a big, energetic shove, and that releases those compounds so much more easily. Scientists can actually measure this energy, and it's what makes hot water so darn effective. And you can see that push in action right here on this chart. If we say a hot brew at 93 degrees Celsius is our baseline, our 100% extraction rate, then dropping the temperature down to 50 degrees cuts that rate in half. And a room temperature cold brew at around 23 degrees, it's chugging along at just 30% of the speed. So you might be wondering, if cold brew is so much slower, why is it so strong? That's a great question. Well, it's because some key compounds, like caffeine, dissolve really easily even in cold water. You still get that instant flavor hit from the fines. The rest of the extraction just takes a whole lot longer, and that's why cold brew has to steep for hours and hours. Okay, so now let's put it all together. When we combine the effect of all those different particle sizes with temperature over time, we don't get some simple straight line. No, we get something way more interesting, a two-speed extraction curve. Remember our two types of particles, the sprinters and the marathoners? They're both giving us flavor at the same time, just in totally different ways. The fines, they give you that immediate, upfront punch of extraction, a huge chunk of your flavor in the first few seconds. Then, the bulk grounds take over, and they provide a much slower, steadier extraction for the rest of the brew time. This combined effect creates a really specific shape that scientists have a name for. It's called a Weibull curve. And honestly, understanding this curve is the real key to mastering your brew, because it shows you exactly how to balance that initial hit from the fines with that long-lasting flavor from the bulk grounds. So, if this whole process is so predictable, why is our coffee so inconsistent? Well, it's because most of our brewing methods are kinda chaotic. And that brings us to the final part of our journey today, the quest for control. I mean, just look at a typical French press. Some grounds sink to the bottom, some are floating on top, the temperature is dropping by the second, and the water isn't flowing evenly. It's totally out of control. The goal of a method like uniform extraction, or UX, is to create an in-control system, where every single coffee particle gets exposed to the exact same stable environment.
And the method is actually beautifully simple. You just use a double-walled container to keep the temperature locked in, and you use a little magnetic stir to keep all the coffee grounds constantly and evenly moving through the water. No settling, no floating, just pure uniform contact between coffee and water.
That agitation, that stirring, is the final key to getting control. Stirring faster is like creating a tiny whirlpool around each coffee particle. This turbulence washes away the already extracted coffee and brings fresh water right to the surface of the ground, which speeds up the whole process in a predictable, controllable way.
And hey, don't just take my word for it. As Professor Stephen Abbott, whose research is the basis for all this, puts it, our everyday brewing methods are basically uncontrolled. The grounds just aren't in a constant environment. But by controlling for temperature and agitation, we can finally take charge of that extraction.
So you see, the inconsistency in your daily cup of coffee, it's not a mystery after all, it's just physics. It's the chaotic dance between particle size, temperature, and an uncontrolled environment. By understanding these forces, you can go from just hoping for a good cup to actually engineering one. So, I'll leave you with this thought. Now that you see the science, how are you going to brew your next cup?